Okay, so let's take a look at the questions on page 529. Number 27 says mountain climbers have placed a 3.6 kilogram uniform ladder across an icy crevice. The edges of the crevice are 4.1 meters apart. Now that's quite a crevice, just in case you're not thinking. 4.1 meters, like that's like putting two people head to head plus a bit more, because no one's 2 meters tall. Well, maybe a few if you are, but okay, so that's quite a crevice. So they put a ladder, which is really only 3.6 kilograms. So it's a long ladder, but doesn't really weigh a lot. Okay, and this whole distance is 4.1 meters. Okay, the edges, the first climber starts to cross the crevice on the ladder and reaches a point. So the first one is here, FG of the person. And they reach a point of 1.8 meters across. Okay, so not quite halfway. It's a uniform ladder, so this will be FG of the ladder. The mass of the climber and her gear is 87 kilograms. Isn't that sweet of the guy? You go ahead first here. I'll hold you on this little tiny rope that you can see in the picture. And the question wants to know, with what force is the ice on each side of the crevice pushing up? So there's going to be an F1. It's really like a normal force here going up, and one here as well. F normal 2. And so the question is to find both of those. Okay, so the weight of the ladder, the weight of the person, and then the two normal forces. So if we did some of the torques, there would be a torque from normal 1, a torque from normal 2, a torque from the person, a torque from the ladder. You need to pick your pivot point. I'd probably pick it here, partly because they give us the distance of person 1 from this side. You want to pick it on one of the two ends because you don't know either of these forces, so you want to get rid of one of them. So let's get rid of N1. And then holding your writing utensil along the ladder, N2 is going to make it rotate counterclockwise, which will be positive, and the two weights are going to make it rotate clockwise, which is negative. So it's going to be positive, negative, negative. So it'll be R normal 2, F normal 2, sine theta normal 2 minus R of the person, FG of the person, sine theta of the person, minus R of the ladder, FG of the ladder, sine theta of the ladder equals 0. If you look at the thetas, they're all 90, so the sine thetas will all become 1. And you're trying to find F normal 2. So take these two terms over, and it'll be positive R of the person, M of the person, G, theta's gone, plus R of the ladder, M of the ladder, G, sine theta's gone, divide by R normal 2. And we can now fill our numbers in. R of the person, it told us in the question, 1.8 meters. The person is 87 kilograms, walking across a 3.6 kilogram ladder that's over an icy crevice. That sounds smart to me. But anyway, just don't ask me to do it. The R of the ladder, it's a uniform ladder that's 4.1 meters wide, so it'll be 2.05 meters. Mass of the ladder, 3.6 kilograms. And then G, 9.81 meters per second squared. And then you're going to divide all this by the normal, how far this normal is from that one, and that'll be 4.1 meters. When you do this, you get an F normal 2 to be 392.352 newtons. Okay, so that's the first normal. Now you need to find the second one, and you have two options. You could move your pivot point over here and just do some of the torques again, or now that you have Fn2, you could just do some of the forces in the y direction. It's not moving in the y, So it'll be Fn1 plus Fn2 minus Fg of the person minus Fg of the ladder equals 0. And you're trying to solve for Fn1, so it'll be m of the person G plus m of the ladder G minus F normal 2 that you just found. So 87 kilograms times 9.81 meters per second squared plus 3.6 kilograms times 9.81 meters per second squared minus 392.352 newtons. And when you do this, you get an Fn1 to equal 496.4339 newtons. Fn1 is bigger than Fn2. Does that make sense? Actually, it does, because the person's closer to the N1 side, so it's taking more of the weight. All right, number 28 is a crane, so it's like a hanging sign again. So you have a cable, you have a boom arm. The angle here is 32 degrees. I have a note beside mine that says B is wrong. The crane with a movable pulley system is on a horizontal arm moving a large container. The 355 kilogram container is hanging from a cable 6.15 meters out on the 7.5 meter long arm. So this time it's not all the way out on the end, it's here, okay? So this is Fg of the container. This is Ft. The arm will be in the middle. So this is Fg of the arm. It tells us this distance is 6.15 meters. And it tells us the whole distance is 7.5 meters. Right? Yeah, and it tells us that the container's mass is 355 kilograms. And the mass of the arm is 345 kilograms. I'm sure we can get these mixed up in the wrong spot, aren't you? And it wants to know first what's the tension. So let's pick our pivot point here so that the force of the pole doesn't create a torque. We do sum of the torques is equal to 0. Should be its torque from the pole that's going to disappear, a torque from tension, a torque from the arm, a torque from the container. Holding it at the pivot point, the tension's going to make it rotate counterclockwise, positive, the two weights clockwise, so negative. So positive, negative, negative. R tension, F tension, sine theta tension, minus R of the arm, Fg of the arm, sine theta of the arm, minus R of the container, Fg of the container, sine theta of the container. These two sine thetas go to 1. We're looking for Ft. So Ft will equal R of the arm, M of the arm, G, plus R of the container, M of the container, G, over R of tension, sine theta, tension. Ft will equal R of the arm, halfway of the 7.5 is 3.75 meters, times the arm was 345 kilograms, times 9.81 meters per second squared, plus the container was 6.15 meters out. Its mass was 355 kilograms, times 9.81 meters per second squared, divided by our tension. It's all the way out on the end, so it's 7.5 meters, and the angle is 32 degrees. Okay? Carefully do the math, and you should get 8582.28 newtons. That's the tension. Part B now wants you to find the components of the force that the vertical, the pole we'll call it, So this is FPX